Hello, hi my dear students. Today we can continue with PN junction diode chapter. In that today we are going to learn about rectifiers. Okay, one of the application of PN junction diode. So, rectifier. Okay, so we can make the heading as rectifier. This is one of the application of PN junction diode. So in this video also we need to know about forward biasing, also reverse biasing. That video we already done, so it is good to refer those two videos before watching this, because we need that concept in this video. So here actually in a rectifier we already studied about forward biasing and reverse biasing, right? In the forward biasing, which is called a true connection, and in this case we can call it as activation mode, where current passes. So activation mode. And reverse biasing, which is a false connection, right? That we can call it as deactivation mode, where current is blocked. Deactivation mode. And next thing, in our home the supply current will come in AC form, right? Alternating voltage, AC voltage, like this, plus half like that, which is AC voltage. But all the electronic devices will not go with this AC voltage, right? They need DC voltage. That means we need a conversion from AC to DC. For that we need a rectifier. A rectifier circuit helps for this conversion from AC to DC. And the process of conversion is known as that process. The process of converting from AC to DC. This process is called rectification process, and for that we need a rectifier circuit which include a PN junction diode. Fine. This much basic things can note. Next we need a circuit diagram. Through that we will explain the process of rectification. Fine. So this is our circuit diagram. Here this is a transformer, right? Here we have primary section where the input is drawn, and this is that secondary coil from where the output is produced. We can mark this end as S1, this end as S2, and this is our PN junction diode, PN. Okay, this is our load resistance where output is drawn, where you can connect a light or speaker to detect the output. Okay, fine. Now how it is working? Here the input is given, right? Here the input is given, and our input is in the form of AC voltage, like this. So plus minus plus, it will go like this. So first case, we will discuss about the first case, case 1. Case 1 for the positive half cycle of this AC voltage. In the positive half cycle, here S1 we can put as positive and this as we can put as negative. That means plus is given to P type. Then its connection will be true connection, right? That is S1 is positive. S1 is positive means it is in forward biasing. Forward biasing means it is in activation mode, right? That is, here the voltage will be there according to Ohm's law IR. So here voltage will be there. We will get voltage in first case, right? So this diagram also it is good to draw. That is, this is our AC input, right? Where plus half, this is our first case, plus to P. That means it is forward biasing, where current flows we will get a voltage because it is in activation mode, right? So that is from 0 to pi. 0 to pi is that plus half. So you will get voltage, that means like this you can draw output as plus. You will get the voltage, right? In the next case, that is in the case 2, in the negative half cycle, in the case 2, you are taking negative half cycle where this will reverse. Here negative, here plus. That means negative to P, if is connecting, it is reverse biasing, right? That is reverse biasing when S1 to negative. That is deactivation mode. Deactivation mode means there will not be any voltage coming to this load resistance. That is V equal to IR, that will be 0. No voltage. So nothing will be there here. So this process continues. Again for plus half cycle, we will go with this case where it will be forward biasing. We will get voltage like this. And the next negative half cycle, nothing. Like this we are getting a DC voltage, right? We are getting a DC voltage without any drop of voltage. But there is a lag of time, right? There is a, after one cycle, there is a lag of time. So for that purpose, we need everything continuous, like this. For that, next rectifier we are using, which is known as full wave rectifier. And this rectifier we studied according to this. We will call it as half wave rectifier. Half wave rectifier. So this is our topic today, which is known as half wave rectifier. In this case, just you need to remember what is a process called rectification. We need to convert AC signal to DC voltage. For that, we need a rectifier circuit. This is a rectifier circuit. We need a PN junction for that. If plus is connected to P, then we will get a voltage. Like this for first half cycle we will get. Here it will be nothing for negative half cycle. Again for positive there will be voltage. So such type of rectifiers are called half wave rectifiers. But next level of rectifier we need, right? In the next class we can study about full wave rectifier. Hope it is clear the class. Bye.